So in the electronic devices and instrumentation laboratory, you'll be studying part B. In the part B, you'll be studying regarding the simulation using EDA software. So there are numerous EDA software available in the market. So we'll be using multisim software to simulate the experiments. So there are two experiments which you need to simulate. So the first experiment would be input and output characteristics of BJT operating in common emitter configuration, and we need to evaluate the parameters. So this is your first experiment, and the second experiment is transfer and drain characteristics of a JFET and MOSFET. So first let us look at the first experiment, which is input and output characteristics of BJT common emitter configuration and evaluation of parameters. Whenever we conduct an experiment, so the first would be to the first thing would be to uh, judge, or we need to decide what's the aim of this project. So the aim of this project is to study the input and output characteristics of an NPN bipolar junction transistor in common emitter configuration, and to calculate parameters like dynamic input resistance, dynamic output resistance. So in order to simulate this experiment, we require some apparatus or the components. So some of the components which we require for this circuit is, the first thing is we require a BJT transistor which should be of type NPN. So we have chosen BC547BP. So this is the name of the NPN BJT transistor. Then we require two resistors of 1 kilo ohm and the other resistors of 100 kilo ohm. So next is we require connecting wires. So the connecting wires are used to connect the components. Next is we require ammeters. So we are requiring two ammeters. The use of ammeter is it is used to measure the current. So this is one ammeter. So you can observe the symbol A which is written here. So it is used to measure current. Again, this is a symbol A which is written here. So there are two ammeters. Then we require DC power supply. So in order to power this circuit, okay, in order to power up this circuit, we require DC power supply. There are two DC power supplies, and we require an voltmeter. A voltmeter is used to measure the voltage. So this is one voltmeter. You can observe the V symbol over here, and this other voltmeter, you can observe the V symbol over here. So we require two voltmeters. So these are the components which are required to simulate the first experiment. And next thing is will be constructing the circuit diagram. So this is the circuit diagram. Okay, this is the circuit diagram. So using this circuit diagram, we will be analyzing the characteristic of the BJT transistor, and we'll be trying to measure the parameters like dynamic input resistance and dynamic output resistance. And so this is your circuit diagram. Next is background theory. So when you say BJT, it's a bipolar junction transistor. It is a solid state device in which the current flow between two terminals, collector and emitter, is controlled by the amount of current that flows through the third terminal, that is the base. So this is what your BJT is all about. Okay, so what I am trying to say that let me show or illustrate that with an example using multisim. So in order to in order to execute the multisim, you just click on this multisim. We will be making use of evaluation version. So click on evaluation version. So this is the window which pops up when you click on the multisim. So here we'll be rigging up the circuit by taking the components. You can view here. So this is called as place source. So when you click on this, so this consists of all the sources. For example, we require DC power supply, So this consisting of DC power, AC power, ground. So whatever the sources which are used to power up the circuit is available here. Okay, so that is available in place source. Next is place basic. So here resistors, okay, resistors, relays, okay, capacitors, all the components will be available here. Okay, next is place diode. So all the diodes like Zener diode, next LEDs, Schottky diode, all these diodes will be available here. Similarly, a transistor. So we are trying to simulate the characteristics of transistor. So transistors will be available here. So these are the transistors. So we will be making use of BC547 BP. Next, similarly all the other components are available here. So next is we require indicators. So indicators means if we require ammeter or voltmeter, so this is your voltmeter and this is your ammeter, and if we require any lamp or something we can look over here. So indicator means the output, okay, at the output if you need to view the output, so it will be through the indicators. So these are the things which you should be aware of. So the first is place source. Here all the source devices, that is powering up devices, will be available here. Next is basic components, that is resistors, inductors, capacitors, and all the other components which are basically used will be available here. Next, diodes will be available here. Next, transistors will be available here, and the indicators will be available here. Here along with the indicators will be able to use ammeters and voltmeters. Okay, all those will be available in indicators. Okay, now coming to background theory, we are talking of BJT. Okay, so BJT means it's a bipolar junction transistor. It will be having 3 terminals. So before that, let us consider simple circuit to illustrate what's the need of a BJT. So let me consider a source. Let us consider DC power source. So this is your DC power source. We are placing it over here. So you might have used batteries to power up some LEDs in your childhood days. So that is what I am trying to illustrate over here. So battery will be indicated by this symbol. So it is 12 volt which is given over here. Okay. Next is we require a ground terminal. Whenever you take a power source, along with that we just need to select one ground source. So I have selected a ground source. Next, let me take some LED. I'll be taking a red LED. So this is your red LED which is used to glow, and let me take one switch. So in your childhood days you might have used this, okay, to power up an LED. So what you used to do, so if we consider here, this is switch. So the switch is having, so the switch is having 2 terminals. So this is your first terminal and this is your second terminal. So now let me connect the LED one terminal. Okay, so again LED will be having 2 terminals. One end, that is positive terminal, is connected here. The other end of the switch is connected to the battery. Just look over here, key is having 2 terminals. So this is one terminal and this is 2 terminal. Again your LED is having 2 terminals. This is one terminal and this is other terminal. So this is positive and this is a negative. So take this and connect to the ground, and this is negative. Okay, so if you look over here, so this is what a smaller length line and this is a larger length line. So whichever is larger, that would be positive. Whichever is lesser in length, okay, that would be negative. Again here, whichever is length is maximum, that would be positive. The length is minimum, it would be the lead was length would be minimum, would be negative. So again this is negative, we need to connect it to ground. Okay, so we'll be connecting this to ground. Okay, now to run this circuit, we need to click on this green button. When you click on this, it starts running. So now the circuit is running. So if you observe here, the switch is in closed position. If we turn this to other position, the LED will be turned on. You just look over here, the LED is turned on. So we can make use of switch to turn on or turn off the LED, right? So you can observe turning on the LED or turning off the LED. So now let us stop the simulation. So now you have turned on an LED using a switch, right? So this is a mechanical switch, so you need to turn it on and turn it off manually. Just think of a switch which can be turned on or turned off by providing current. Okay, we'll be using current to turn on or turn off the LED. So if that's the case, we require a device called as a transistor. Okay, this is where the transistor comes in. So I have picked up transistor here. This is your transistor. So here, instead of turning on the LED and turning off using a switch which can be operated manually, we can make use of a transistor which can turn on or turn off the LED using current. So this is your transistor. So the transistor will be having three terminals. So it would be base will be so it's a three terminal device. So this will be called as a base, and you'll be calling this as the collector, and you'll be calling this as the emitter. You can watch the arrow head over here. So whenever it is pointing outwards, it would be a NPN transistor, and the arrow pointing end terminal would be called as emitter. So you just remember that it is made up of three terminals: collector, base, and emitter. Okay, so instead of connecting switch, let us connect the transistor. Now so instead of switch, I replaced it with what? A transistor. Now let us run the circuit. Still the circuit, although it is rigged up, okay, it is not, the LED is not glowing. Why is it? The reason behind that is, in order to turn on this, we need to provide current. Okay, we need to provide current at the base. Okay, we need to provide current at the base. Okay, so let us take a ammeter. Just place it over here. So as you know that ammeter is used to measure the current. Okay, so if we provide current to this base, okay, if we provide current to this base, okay, the transistor will be turned on. So by turning on the transistor, you'll be able to turn on the LED. Okay, so we need to provide current to this. So in order to provide the power, that is current, let us take another DC power supply. So this is your DC power supply. Let me make it as around 2 volts. Okay, let us take one resistor. I'm taking one resistor. And I'm placing this over here. So this is your positive terminal. Positive of the ammeter should be connected to the positive of the battery, and the negative will be connected to the ground. So here all the negative terminals should be connected to a common ground. Now we are connecting the ammeter negative to the base. Now we are able to provide the current to the base. If we are able to provide current to the base, it turns on the LED. Okay, now let us run this circuit. Still what is happening? The LED is not glowing. The reason behind that is the current which you have provided here, okay, the current which you have provided here is not sufficient to turn on this LED. So let us increase this current. You can observe here it is 0.222 microamps. Let us increase this current. Okay, now you observe the LED is glowing. When you provide sufficient amount of current over here, okay, when you provide sufficient amount of current over here, the LED is glowing. Okay, so by providing sufficient amount of current, we can turn on the LED or we can turn off the LED. Okay, so now we just need to know what is the exact amount of current which has to be provided to the base terminal in order to turn on this transistor. That is what your first experiment will be. Okay, in order to know this exact amount of current which is provided to the base terminal to turn on the transistor, we require to study two characteristics, that is input characteristics and output characteristics. So that is what we'll be learning in your first experiment. Okay, so first let us study the input characteristics. So in order to study the input characteristics, we just need to rig up the circuit. So first let us rig up the circuit. So this is your circuit which has to be rigged up on the multisim software. So let me open the multisim software by clicking here and click on evaluate. So we need to select the components. So the components are, we need to take one transistor. The name of the transistor is BC547BP. Okay, BC547BP. So in the you can look over here. So when you place the cursor over here, okay, it shows its place transistors. Okay, you can observe this is your place source. Okay, this is your place source, place basic, place diode, place transistor. In the place transistor, you click on place transistor. Okay, here in the place transistor, this is your transistor. Okay, you need to click on BJT NPN. Okay, BJT NPN. So first thing is you click on place transistor. This is your transistor group. In the transistor group, you click on BJT NPN. Then here type the name BC547BP. Okay, so this is a transistor which you will be using to study the input output characteristics. There are numerous transistors available in the market, so we will be studying only the characteristic of this NPN transistor. Okay, we have placed the transistor. Next, all the components we require. We require two resistors. Okay, we require two resistors of 1 kilo ohm and 100 kilo ohm. Now, so the resistor will be available in basic. Okay, click on place basic. So in the basic, you need to select a resistor. Okay, in the basic you need to select a resistor. Here 1k resistance is already selected. You just click on OK. So it places, and click on the window. Okay, it places 1 kilo ohm resistor. Okay, so in order to get another resistor, so you require two resistors, right? You can just click on this, then select this, Control C, Control V. Okay, so it copies and pastes the component. So there are two resistors. Okay, but the value of one resistance is 1 kilo ohm, so we can manipulate this by clicking on this. Okay, just double click on that. So here the value is what, 1k, but what is the value which we require? 100 kilo ohms. Okay, 100 kilo ohms is the resistance value, so you change this value to 100k. Okay, so this is 100 kilo ohms. Okay, now you have got a transistor, you got two resistors. Let us look for other components. So you require what? Two voltage sources. So in order to get voltage source, so place source, click on place source. So here we need to click on power sources. We require DC power, so click on DC power and click on OK. So now click on this window. Okay, it places the DC power source. So one DC power source is already present in the circuit window. Okay, we require other power source, we can copy it later from the same source. So we require what? A ground terminal. So whenever you place a source, there should be a ground along with that. So click on ground and place the ground terminal. Okay, so as I said, already one source is there. Control C, Control V, so that copies and paste. So Control C for copy, Control V for paste. Okay, so all the components, got all the components. Now we require meters. We require two ammeters and we require two voltmeters. Okay, so let me pick up ammeters and voltmeters. So it will be present in the indicators. Click on place indicator, then ammeter. We require two ammeters, so this, click on OK. So there is one ammeter, again you pick another. Okay, so there is two ammeters. Okay, next we need to pick two voltmeters. Click on voltmeter, click OK, place here again. So here V means vertical, H means horizontal. Okay, you select vertical. Okay, so it would be easier. Okay, click on another voltmeter. So now all the components and the meters are available. Now what we need to do, we just need to connect one another, that's it. So first thing is what? Align all the components properly. Let me keep this voltage over here. So this is your resistor and this is your ammeter. Okay, next this is your resistor. Just look over here. Next this is your ammeter. Next this is your voltmeter. Now make the connection. We connect positive of this to resistance here. The resistance, you just need to single click and select the point and drag and drop and click at the other point. When you place the cursor at this location, it shows a circle, then click over there and you just drag by keeping your left mouse button clicked and leave at the position where it shows there is a connection and click over there. Okay, so I connected here, then again bring the cursor here, it shows a circle, click over there, then keep your left mouse key pressed and drag it and leave at the position where the other end is present and click over there. Okay, so it connects. Next, this has to be connected again. I click here, drag and I click at this position. Okay, so similarly you connect this. Okay, so that is the connection. Next, you click here, drag it by clicking the left mouse key and one click at the ending of the terminal. So next, click here and you connect this, and this is your emitter. Connect it to the ground. Okay, now we require, so the connection is over, we need to connect the voltmeter. So you can observe here, this is positive and negative, so may always make sure that so the positive and negative terminals are connected properly. So the negative has to go to the ground. Okay, ground means there is nothing but negative. Okay, so negative connecting here, so this is your positive, we are connecting here. So next, this is your positive, let me connect here, and this is your negative, I will be connecting it to the negative terminal. So this is the circuit, so that completes the circuit. Okay, so connected all the terminals, and this is how the terminal would look like. Okay, so connected, you can connect this terminal to here, or you can also connect to here, it's one and the same. If you want to connect this to here itself, what we need to do, you just select the line, then shift delete, it deletes that line, it's a wire, you click here and then you can click here. Okay, so that completes the circuit. So this is your circuit, and the circuit is ready to study the first experiment. Okay, and now you just need to name the terminals. You can observe here, I have named it as IC, VBE, IB, VC, or VBB. So what are those terminals? I'll be explaining it here. So you know that when we consider a transistor, it will be having three terminals. So this is your base terminal, and this is your emitter terminal. Wherever there is an arrow indicator, so that will be your emitter, and this would be your collector terminal. Okay, when we provide sufficient amount of current from this voltage source, okay, so this is your current, so this current comes over here and it enters here. The current which is entering into the base terminal will be called as current IB. Okay, and the current is coming from here also, right? So this current is entering here into the collector, so this is called as collector current, and the current which is coming out of this emitter terminal is called as current IE. Okay, so there are three currents, IC, IB and IE. Right now we are concerned only with current IB and IC. So ammeters, there are two ammeters which are present over here. Okay, this is used to measure the current IB, so this can be named as what, IB, and this ammeter is used to measure current IC, so this can be named as what, IC. So let me name this. Okay, let me name this as IB. So double click on this, okay, and then go to labels. In the label you name this as IC. Then in the display you click on use schematic, you uncheck, okay, you just uncheck the show values, show reference and show attributes, and click on OK. You should click only that show label should be viewable. Okay, so you just right click, that is put a right mark in front of only show labels in the display. Okay, then click on OK. So you just look over here, it is showing only it is an IC. Okay, now we have labeled it as IC. So this current, okay, that current which is entering into collector is called as what? IC. Similarly, we need to name this as what? IB. Okay, double click on this label, name this as IB, then go to display, you click on this, you uncheck show values, show reference, and only the show label should be checked. Okay, then click on OK. Okay, now this is showing only IB. Okay, the current which is entering into the B is what? IB, right? So now you know this is IC which is entering into collector, this is IB which is entering into the base. Next, this is what? Voltmeter. Okay, voltmeter is used to measure what? Voltage. Okay, this is measuring the voltage between what? This is your base and this is your emitter. This voltage meter is measuring the voltage between what? Base B and E. So you can name this as what? VBE. Okay, this voltmeter is measuring the voltage between what? B and E, so it can be named as what? VBE. Similarly, this voltmeter is measuring the voltage between what? C and E, so this can be named as what? VCE. Okay, so here this voltmeter is measuring the voltage between what? C and E, so this can be named as what? VCE. Okay, now let us name that as VBE and VCE. Let us name this as VBE. Go to label and name this as VBE, then go to display, uncheck this and click on OK. So this is named as what? VBE. Now we need to name this as what? VCE. Double click on this, go to label, name the label as VCE, and go to the display, uncheck this one, only show label should be checked and all the others should be unchecked, then click on OK. This is your VCE. So now, so this is your IC, and this is your IB, this is your VBE, and this is your VCE. So just look over here. So this is your VBE, VCE. Just look over here, VBE, VCE. So this is your IC and this is your IB. Now the circuit is ready to study the. Not to study the characteristic, let us name this as VBB and this as VCC. So the reason behind naming this as VBB is, so here this voltage is being fed to base, so it's named as VBB. So let us name this as, label it as VBB, and go to display, uncheck this one, uncheck this, uncheck and uncheck. But in case of power supply, so since it's a power supply, we also need to check the show values. Okay, so this is your VBB. Now we need to name this as VCC since this voltage is feeding the collector. So you name this as VCC, go to display, uncheck this, uncheck these two things. So label and value should be checked for power source. Click on VCC. Now in order to study the, so this is your circuit, the entire circuit is complete. Now in order to study the two characteristics, that is input characteristics and output characteristics, the first thing what we need to do is we need to ensure that both VBB and VCC is set to 0 volts. We made this this is already 0 volts, If it is not 0, you make this as 0. So voltage is a 0 volt. Click on OK. Now this is 0 volt and this is 0 volt. Now you run this circuit. You can observe here the voltage is 0, voltage is 0, the current and voltage, everything is 0. So this is the initial adjustment which we need to make. Now stop this. Now let us look the procedure for input characteristic. So input characteristic means, so this is the procedure for input characteristic. So in case of input characteristic, so first thing is we need to make the circuit connector, which is as shown in the circuit diagram. So you already made the circuit diagram. Next is set the voltage VCE equals 2 volts. So what is VCE? So this is your VCE. We need to set it to how much? 2 volts. So in order to make this as 2 volts, we will be adjusting VCC. Okay, if we provide voltage here, the same voltage will be appearing here. Okay, so we adjust this voltage VCC in order to make this as 2 volts. So that is being given here. Set the voltage VCE is equal to 2 volts. So let us make this as 2 volts and click on OK. And now run the circuit. You may observe here. So this is set to what? 2 volts. So your VC is set to 2 volts and VCC is 2 volts. Okay. Whenever the circuit is running, okay, so you can observe green glowing LEDs over here. Okay. Whenever you stop this, so there will be no green light showing over here. Okay. So that indicates the circuit is not running. Okay. Now you set the VC equals 2 volts and vary IB with the help of VBB. So what they are telling you is you need to vary this current IB by varying VBB with the help of VBB and measure VBE. So what they are saying is you need to vary current IB which is entering into this base terminal. In order to vary this current, the source of current is from this voltage, so you need to vary this voltage, and when you vary this voltage there will be some current which is entering here and there will be some voltage which will be existing across base and emitter, so that will be called as VBE junction. Okay, so when you vary this VBB, okay, the current IB will be shown and current VB will be shown. You just need to take down these two readings. Okay, so that has to be entered into the tabular column. Okay, so this is the tabular column. So if you come here, this is the tabular column for input characteristic. Okay, so your set VC E. Okay, this is your VCE. You set VC equals what? 2 volts. Now what we need to do? We need to vary VBB. You need to vary VBB and measure VBE, this voltage, and IB, this. Okay, IB, this has to be noted down. Okay, so your VCE is 2 volts, which is already being set. Now we need to set VBB, so this to 0.2 volts. Okay, let us make this as 0.2 volts. Click on OK. So VBB is what? VBB is 0.2 volts. Now you run the circuit and note down what? VBE and IB. So now let us run this circuit. So when you run the circuit, you can see over here what is VBE. It is 0.195. What is your IB? It is 0 amperes. So note those readings here. So the value of VBE is how much? 0.195 volts. 0.195 volts, and this is 0 amps. Say this one. Now what should do next thing? You make VB as 0.4. So you stop this, you make this as 0.4 click on OK, then again run the circuit. Now you observe here the value of VBE is how much? 0.391, and still the value of IB is how much? It is 0 itself. Okay, so it would be 0. Okay, it as okay. Next, stop the circuit. Next, you make it as 0.6. You make this as 0.6. Click on OK, then again run this. So now you may observe some amount of current over here. Okay, just observe here at 0.6 the voltage is how much? 0.560, and the current is how much? 0.222 microamperes. So you can see there is some amount of current, 0.222 microamperes. Okay, the next thing is what we need to check for? 0.8. Stop this, click on this, make it as 0.8. Click on OK. Now click on run. Now is to observe here for 0.8 the voltage is how much? 0.616, and your IB is 1.665 microamperes. Save this one. Then the next value is check for 5 volts. Stop this one. Check for 5 volts. Okay, let us run this circuit. So for 5 volts, what is the voltage here? 0.662. so it was 1.65 micro. Now you observe here it is 43 microamperes. It is 43. It is showing in milliamperes. You can write this as what? 43 microamperes. Okay. And next, you check for 10. Stop this. You click on this. Make it as 10 volts. Next, you need to run this circuit for 10 volts. What is the value? 0.669 is your VBE, and 93 microamperes. Next, you stop this, save it, and you stop this. Next, you need to check for 15 volts. You make this as 15 volts, then click on OK. Run this. So it's showing 0.675. 0.675 is the voltage. What is the current? 0.14 milli. So it can be written as 143 microamps. Next, you need to check for 20. Stop this. Check for 20 volts. Click on OK. Run the circuit. So what is it? It is 0.680, and the current is 193 microamps. So you have taken the readings for input characteristics. Okay, this is the characteristic. You just look over here. As you are increasing the voltage of VBB, so what is happening here? So VBE is increasing. At some value it is remaining almost constant, but what is happening to the current? So the current is increasing. Okay, so the current is increasing. It started from 0 and now it has reached 193. Now you need to plot the graph for this. Okay, you need to plot the graph for this. So how do you plot that? So this is the graph. You take VBE along x direction and IV along the y direction. So at 0 volts, at 0.1 volts, so you have taken the readings here at 0.2, 0.4. So just take x axis as VB at 0, 0.2, 0.4, 0.6, 0.8, 1. So you look over here, as your VB is increasing after 0.6. Okay, after 0.6, just look over here, after 0.6, so the current is increasing, the current is increasing exponentially, the current is increasing exponentially, but the voltage is remaining as it is. Okay, you just look over here, the current is increasing but voltage is at the same value, 0.662, 0.669, 0.67, 0.668. so this is remaining as it is. Okay, so observe here, see this value is what? VBE. Okay, it's this, we are plotting the graph of what? VBE and IB. This is not VBB, don't get confused. We're plotting the graph of what? VBE versus IB. So VB is varying from what? 0 0.1, 0 0.3, 0 0.5, 0 0.6. so that is what is being given over here. Okay, after 0 0.6, so the current is increasing rapidly. Okay, so that is what is being given here. Here instead of VC is equal to 10 volts, what you have considered here? You considered VC equals what? 2 volts. Okay, when you plot the graph, so this is what your data would look like. Okay, it resembles this graph. Now we have carried the operation with VC equals 2 volts. Now you take the second reading. Okay, you take the second reading with VCE is equal to 3 volt and repeat whatever I explained earlier. Okay, the only change is what? Is stop this circuit. You make VC is make everything as 0. Let us make everything as 0. This is 0 and this is 0. Now run the circuit. So everything shows 0. We ensure that everything is 0. Now stop it. Now again start with 3 volts. Now run the circuit. So your VC is showing 2.99. That's almost equivalent to what? 3 volts. Okay, now your VC equals 3 volts. Okay, your VCE, okay, your VCE equals 3 volts. And now you vary the VBE. You vary VBE by varying VBB and check out VBE and IB. Okay, so stop this one. You make this as 0.2. Click on OK. Run this. So it is showing what? So VB is how much? 0.15, 0.195. What is your current? IB, it is 0. Okay, next you need to check for what? 0.4. We stop this, make this as 0.4. Click on OK, then run the circuit. So what is it? It is 0.391. so it is showing what? 0.391. What is the current IB over here? It is 0. And next you need to check for 0.6. Check for 0.6. Click on OK and run the circuit. So what is it? The value is how much? 0.56, 0.560. So what is it? 0.22. 0.222, and next let's stop here. Next make it for 0.8, 0.8, run the circuit. It is showing 1.66, so it is 0.616, and here it is 1.665 microamps. Just look over here, the current is 1.665. okay, now stop the circuit. Next make this as 5 volts. Click on OK. Now run the circuit. So this is 0.672, but 5 volts it is how much? 0.672, and the current is 43 microamps. Then stop the circuit. Next check it for 10 volts. 10 volts. Click on OK. Now here 0.677, 0.677, current is 93 microamps. Next stop this. Next make this as 15 volts. Click on OK. Click on OK and run this circuit. So it is 140. So 0.6882, and here it is 143. Next check it for 20. Okay. So now for 20 again it is what? 0.686, and the current is 193. So now got other set of values. This is almost resembling what for VC is equal to 2 volts, whatever the voltage you have set, the same readings you are getting here also. Okay, so you do one thing. So for instead of VC is equal to 3 volts, you make VC equals 6 volts. Okay, VC equals 6 volts, and repeat the readings again. So for example here, let us clear this. So for VC is equal to 6 volts. So the first thing is you need to make everything as 0. Click on OK. Make this as 0. Click on OK and run this. So everything is 0. Now make this as 6. Click on OK. Okay. Now the circuit is ready. Now we simulate by one. For first one, for 0.2, for 0.2 it is 0.195, and the value of current is 0. Okay, we continue on in the same manner. I'll be checking for the last reading at 20. If I make this as 20, okay, 20. sorry, for voltage 20. So for the voltage 20, so what is it? It is 0.699, 0.699. So what is the current? Is 0.193. That is 193. Okay, 193 microamperes. Okay, so this is what will be doing. Okay, you do it with Vc equals 2 volts and Vc equals 3 volts. So you set the voltage here and you vary this Vb. Okay, so after whatever may be the Vbb voltage, after 0.699, so the current start rising in this fashion. Okay, so that is what is being shown here. Okay, so it is increasing almost exponential. It started from 0, 0 0.22, 1 point, next it is 43, next 93, 143, 93. Okay, so this shows the input characteristic. This is the plot of what? Input characteristic. So now we need to calculate the dynamic resistance. So you know that uh, V equals, you are aware of the formula V equals I into R. V equals I into R. So what is R? So R will be taken as what? V by I. R equals V by I. So we are calculating this resistance. Okay, calculating this resistance at what? Input. Okay, we are calculating the resistance at the input. So it's called as what? Dynamic input resistance. Okay, dynamic input resistance. You are calculating the resistance at input, and the calculation is what? Dynamic. It is changing. Okay, so change in delta VB. So this is what? VB. Change in delta VB to the change in delta IB. So IB is also changing. As VB is changing, IB is also changing. Okay, so the change in this. Okay, delta of VBE. So delta of VBE and change in current IB. So that gives you what? Input resistance. So you need to calculate this dynamic input resistance by using these two things: VB, delta VBE and delta IB. Just substitute these values changing and substitute that will give you dynamic resistance. Okay, so this is regarding the input characteristic. Okay, this is regarding the input characteristic. Next we will be studying the output characteristic. Measure the output characteristic. So in order to measure the output characteristic, what you need to do is the same thing. First you make sure that the sources are 0. Make this as 0. You make this also as 0. Okay, now run the simulator. So everything is shown 0. So now stop it. Now let us look at the procedure for output characteristic. So the first step is keep IB constant, say at 10 microamperes. So what they are saying is you need to make this as a 10 microampere and vary VCE and note down the collector current IC. You need to keep this as 10 microampere. So that is what is showing in this tabular column. So here. So this is output characteristic. So this is the tabular column for output characteristic. So first thing is you need to make this as what? 10 microamperes. Then you need to vary VCE. You need to vary VCE. Okay, how do you vary VCE? By varying VCC. So by varying VCC, you will be varying VCC. So you keep IB as 10 microampere and you go on varying this VCC, that is 2, 4, 6, 8, 10, 20. Then you measure the value of what? VCE and IC. We need to measure VCE and IC. So that is what your output character is. Okay. Let us first line the first step. Keep IB constant, say at 10 microamperes. So IB equals 10 micro. Let us set this to 10 microamperes. So in order to set it to 10 microamperes, let us make this as 4 volt. Let us check this. So this is showing 34 microamperes. So let us make this as 2 volts. Let us see here. So it is showing 14 microamperes. So let us make this as 1.8. Okay, at 1.8 it is showing 12 microamperes. Make this as 1.7. Now run this. So this is showing us 11 microamperes. Let me make this as 1.6. Run this. Okay. This now right now at 1.6 volts, it is showing us 10 microamperes. So set IB. Okay, you just observe here. Set IB to 10 microamperes. Okay, set IB to 10 microamperes. Now what we need to do? We need to vary VCE and note down the collector current IC. Okay. Now what we need to do? Here IB is 10 microamperes. You make this as 2 volts. And first stop this. We have made this as 2 volts. Now run this. So what is the node on the VCE? What is VCE? 0.12. 0.122. What is your IC? So it is 1.878 milliamps. Okay, what is it? 1.878 milliamps. Next, you make this as, you stop this. Stop this. Next, you set VC. You set this to 4 volts. Click on run. Now you can note over here it is 1.36. 1.360. What is the current? 2.64. 2.640 milliamp. Next, you stop this. Next, you change it to 6. Change this to 6. Click on OK. Run it. Note on the VCE and IC. It is 3.293 and current IC is 2.707. 2.707. And next, again stop this. Make this as 8. Click on OK. Run this. Again note down the voltage. VC is 5.226 and the current is 2.774. Then stop this. Make this as 10. Voltage is 10. Click on OK. Now run this. So the voltage is VC is 7.15 and the current is 2.80. 2.840. Let's stop this. Next, let us look at it at 20, and let's make this as 20. Click on OK. Now run this. Let's note down the values at 20. The VC is 16.824. The current is 3.173 milliamps. Next, let us look at it at 30. 30. Now run the circuit. So voltage VC is 26.490 and current IC is 3.507 milliamps. Next, let us look it for 40. Now run the circuit. So the VCE is 36.15 and the current is 3.837 milliamps. Now we have got the tabular column reading VCE and IC. Repeat the same experiment, okay, whatever I have shown you, with IB equals 20 microamperes. Okay, now what I have done is I have kept it as 10 microamperes. You make this as 20 microamperes and repeat this experiment. Okay, how do you do that? First stop this. You set this to first set this to 0 volt. Okay, let me make this as to 3.12. Let me set this to 3. So we need to make this as 20 microamperes. Okay, we just look over here. If you make this as, let me take this as 3 volt. So at 3 volts you are getting 24. Just reduce it to 2.7. You can see 2.6. Okay, at 2.6 volt you will be getting 20 microamps. Okay, so at 20 microamps again you perform the same operation, that is vary this voltage, note down VCE and IC. You will be getting the tabular column readings for the second readings. Okay. Next, after that what you need to do is you just need to plot the graph. What is that graph? This is VCE, so have the readings for VCE and IC. We take VCE along the x-axis, we take VCE along the x-axis and IC along the y-axis. We take VCE and IC. Don't take this VCC value, you just take VCE and IC. So it starts from 0.1, okay, 0.1, 0.2 up to, you just look over here at 1.3. So where is the current? For 10 microamperes. Okay, so at 1.3 it is increasing up to how much? Around 2. Okay, so after that, okay, you're going on increasing the value, okay, up to, you just look up to 16, okay, up to 7.5. so the current is almost linear. Okay, the current is almost linear, so just it is increased from 1 to 2.6. From here it has increased to 1 to 2.7. It is remaining as 2.7, 2.7, 2.7. Only there is a slight change of 2.8. Then after 16, okay, up to 26, it is increasing again. It is remaining as 3.17, 3.17. This is for which reading? For 10 microamps. So for the base current of 10 microamps. Next, for base current of 20 microamps, okay, for the base current of 20 microamps, what happens is the collector current would be increasing and it would be remaining constant. Okay, so that is what the experiment shows you. So this is regarding the output characteristic. Next, how do you calculate the dynamic output resistance? So here it is, dynamic output resistance. So dynamic output resistance, so we are calculating the voltage and current at the output. So what is resistance? V by I. So we are calculating resistance at the output, so we will be calling that as output resistance, and we are calculating it dynamically by taking this as change in VCE divided by change in IC. So it's called as dynamic output resistance. Okay, so this is regarding the first experiment. Okay, that is plotting input characteristic and output characteristic and measuring the parameter like dynamic input resistance and dynamic output resistance. So the link for this Microsoft Word document will be provided at the bottom of the YouTube link. Okay, the link will be provided at the bottom of the video. You just download this and take the printout and bring it to the lab. While coming to the lab, you need to simulate it and you need to enter the readings by yourself. Okay, thank you.